Thank you very much, Christine, and welcome to today's seminar. We've assembled this distinguished panel today, and I'm excited to tell you who they are. First up is Bob Henderson, who's an old friend of the Raleigh section. Bob is now the Director of Lighting of RAB Technology, but he's been in lighting in the Raleigh section for many years at Progress Energy and at Cree. We also have, after Bob, we have Aparna Sproelich, who's the founder and principal of 1B Group. Aparna has also many years of experience, not only in the lighting industry, but in other product development and market development opportunities. She has worked at Cree as well, and now currently consults and supports OEMs in both lighting and electromechanical components. And the third member of our panel today is May Zakerin. May also has over 3 decades of experience in lighting in a variety of roles, as you can see at Cree and other places as well. May is currently the manager for LiteSource Technologies, and we look forward to hearing from all 3 of our panelists today. To give you an idea of how the webinar will proceed, a few minutes for introduction and objectives from myself, then we'll get into the bulk of the material. Bob will concentrate on some of the science of UV disinfection technology. Aparna will talk about the impact of UV radiation on humans, and Mai will tell us some technology solutions. I'll come back at the end and highlight some takeaways that the panel has prepared that they would like for you to remember about today's conversation. And if there are any attendee Q&As, we'll address those as well at the end. So for today's session, there are 4 main learning objectives that we'd like for you to take away. The first is to learn what germicidal or GUV radiation is and the science behind it and how it works. Does it really work? What type of disinfection can you expect? The second is to explain the potential positive and negative impacts of GUV radiation and UV radiation in general on humans. The third is to discuss the GUV disinfection technologies that are available on the market today that are effective at germicidal disinfection. And last, we'd like to go over why this information is important to a lighting practitioner and why it's critical for you to start learning this information now. So with that introduction, let me turn it over to Bob and let's get our panel started.
Okay, Lynn, thank you very much. Hello to all my friends out there. I know many of you, and for those I don't, I might look forward to meeting you. So if we start with this slide, pandemic 2020, COVID-19 virus. So everyone's life has been turned over. We're in quite a mess right now, and we have hopes of a vaccine in the near future. And so if I ask you right now, has your life been changed? I know with full confidence, I'm going to get a 100% yes, because it really has affected everyone. And so the goal first is to get through this next few months until we can get our vaccine, and then we'll go from there. And so, but we're not going to be done. So in the future, there could be something else happen. So what we want to do is to talk about this particular science behind this UV. So with that, so first of all, why should I learn this? So first of all, it's going to affect my job. I do like to eat, and I'm sure you do too. So we really do need to learn this because it's going to be part of our work. The second thing is I have an opportunity to be part of the solution. And so everyone has customers, whether internal or external, whatever. So we want to be able to contribute and be part of that solution. And next is we can learn something new. So most part, the lighting practitioner has not really been dealing with this UV germicidal. And so we can enhance our career by learning this. And last is the train is moving. And so it's a matter of when will you jump on? Will you jump on tonight? Will it be next month? Will it be next year? We're going to invite all of you for these reasons to jump on tonight and start learning the basics, the 101 of germicidal UV. So first of all, what is UV radiation? So ultraviolet is invisible to the human eye. So if we look at this, we've been used to talking about the visible spectrum. That's 380 nanometers to 780 nanometers. And for those of you who may not know, a nanometer is 1/1000th of a meter. So, but we're not going to talk about this spectrum today. What we're going to talk about is just to the left of this visible spectrum, which is, you see this ultraviolet. So as we move forward, and we're going to, first of all, look at the long wavelength. So UVA is 315 to 400 nanometers. So this is what we use in a tanning bed. It's very common there. And then UVB is 280 to 315. So it's used to treat plaque psoriasis and other skin conditions. And we're going to focus mainly on UVC. So UVC is from 200 to 280 nanometers. Now there's one more over here, and that's the 100 to the 200 nanometers. And that's really absorbed by air, and it's only available in a vacuum, so it really not going to really apply. And we're not really going to be focusing very much on A and B. We're really going to hone in and focus on C. All right, so UV radiation background. So if we start in talking about the sun, A and B radiation, well, it's what we just said. It causes sunburns, premature skin aging, and it can lead to skin cancer. And we want to stay away from that. So the man-made UVC, it can be used, and it has been in the past, and it is continuing to be used to disinfect surfaces and water, and it's been used for a long time. We're going to look at the history here in just a few minutes. So UVC is strong enough to destroy the genetic material. So you've got the DNA and you've got the RNA of viruses and bacteria. So we're beginning to pick up some new terms here, DNA and RNA. And then we're also talking about viruses and bacteria. That's going to become a little bit more important very soon. And UVC is germicidal. Germicidal is UVC. So those are really interconnected, and that's what that means. And then last is UVC. It has actually the most energy of all the types, and it is the most harmful if used incorrectly, but thank goodness it doesn't reach the Earth's surfaces from the sun and so forth because of our atmosphere absorbs it. So now we've been introduced to a little bit about the focus on UVC. So let's do a little history. So back in 1908, a long time ago, so UVC was used to disinfect water over in France. And also, everyone knows who Westinghouse was. He developed the first commercial UVC germicidal lamps, and that was used back in the 1930s. All right, so let's move forward. And so there was a time when we did not have antibiotics, we didn't have vaccines. So for air disinfections in schools and hospitals, and really many other public buildings, since the 1930s, before those came out, this is what we used. And this is really kind of all we had. And so we still use this to reduce transmission of tuberculosis. It's still used. Of course, that's an airborne disease. And then primarily used for sterilization in hospitals. Of course, it's unoccupied spaces, and we'll be getting into that shortly. So how does UV disinfection work? So here, this UV iridescence. Now that's a new term. So this is what this iridescence is. Induces damage to the RNA of COVID-19, which is what our focus is for tonight. And so it renders that it's harmless. So that's the idea of how this UV affects this. We're going to get into more of this later. Now, one important thing we want to clarify, you're going to hear the word kill or deactivate. So let's clarify this. So first of all, we kill bacteria. We deactivate viruses. Viruses are not living, but we deactivate those. Bacteria is living. So the proper terminology is kill bacteria and we deactivate viruses. Now let's talk about the germicidal UV radiation. So this is pulling out of the handbook. So it's really defined, as we said earlier, it's from 200 to 280 nanometers in length. So if you look at this little chart over here, this peak out of this chart is 265. You'll notice before that 265, you have less of a value as far as efficiency. And then after that 265 in higher numbers, you have less. So the peak efficiency is right at 265 for the peak germicidal wavelength. Now, if we're 6 inches away from the surface, UVC can kill the average bacteria within 10 seconds. And of course, depending on the power. Now, that's a new word we're using and introducing tonight. Power, that is a correct word. And then also it says what? In line of sight. So this is talking about surface. It's talking about you can kill the bacteria, and this gives you a guideline here within 10 seconds, but it says it can. It doesn't say will, it says it can, because there's some depending factors that we want to learn tonight. Okay, so UVC is usually sufficient, again, focused on usually, sufficient to kill bacteria. See, we're using the word kill bacteria, and then we're using the word deactivate viruses, including the coronavirus, SARS-CoV-2. So that's good to know. Now we're kind of establishing some baseline terms. Okay, so can UV radiation destroy viruses and bacteria? Simple answer is yes, it can, but it depends on dosage. So now we're moving one step forward and we're going to talk about dosage. So the metric for deactivating a virus is a log, a logarithmic log units of reduction after a disinfection treatment. That's a new term, but that's what we use in this industry for this metric for deactivating a virus. So a 1 log disinfection is a 90% reduction in the virus. That means 10% remain. If you have a 2 log, then that's 99%. And now watch out what happens. A 3 log is 99.9. You see the 3 digits? Okay, so 99.9. A 4 log disinfection is 99.99, 4 digits, 4 log, and 5 and so forth, right? So now you're going to hear the word kill with this also. You're going to hear the word like 3 log kill. So disinfection is really a more correct term than kill, because what did we say earlier? We don't kill viruses. We deactivate them, and we disinfect so that we deactivate them so they can no longer be effective on us. All right, now, the big question is, after the disinfection treatment, how effective was the dose application in deactivating the virus? Wouldn't it be terrible if we went through all this expense, all this trouble, and we didn't quite measure up to what we want to do? So really the big important thing is deactivating it and really doing a 100% job so that we get what we pay for, right? That's really important. So let's talk about the UVC and the dose. Now, this is probably, if I had to pick one thing from tonight that I would love for you to take away from and learn, it's this right here. So the exposure dose depends on the UV source strength in watts. That's what we call it, source strength. Wavelength is a subset of source strength in watts, okay? That's the first thing. Second thing is the distance from the source. How far are we away from the source of what we're disinfecting? Now, this is very, very similar to this over in lighting when we talk about this, and you see it's 1 over D square. So if you have lumens and you have a foot candle and so forth, and you're 1 foot away and you 1 foot square foot area, you've got 1 foot candle. But what happens when you go to 2 feet? It's squared. So you see it's 1/4 of a foot candle. This works the same way over here with the distance from the source. The third item is the time of exposure. So how long do I need to run my machinery in order to have a successful disinfection? So this is really important. And again, the most important thing that I think, these are the variables. So you can say, well, what if I buy X? Well, it depends on the variables of these 3 things. So now the other factors that are also come into play is the geometry of the room. Okay, so it could be, like an RCR of lighting. So if you have a high RCR, you have a low CU. So a geometry of the room becomes also as a factor, and shadowing. What about if I'm lighting, let's just say an analogy would be, let's say a classroom, and you're going to light that desktop. Well, what about under the desk? So let's turn that back over to shadowing. Yes, it will not disinfect under the desk because there's a surface that's stopping that. So that's the other thing. Medium being disinfectant. So what is the kind of surface that you're disinfecting? Is it air? Is it water? What is it? And then the air changes. Those are all other factors, but the main 3 are what we just discussed. So different doses may be needed for different pathogens. One doesn't fit all. In the old days, when the medicine man sold 1 bottle to cure all ills, we know that's not true. And so it's the same thing here. So the pathogens vary. And so you may need different doses for those. And then, now let's bring this a little bit over to home. So the assurance for a successful virus deactivation, it's hard to get. If it was easy, we wouldn't be doing this tonight, right? You could just place your order, go pick it up. It'd be a consumer good and no big deal. But that's not the case. So home disinfection often does not have the level of precision that it needs. It can have, but often does not have. Also, home application can offer a false validation. It can say, hey, we've done what we're supposed to do, but it may not be valid for the reasons that we've talked about so far. All right, so let's do another comparison here, and let's talk about light measurement versus UV measurement. So over in lighting, the illuminance is measured in the amount of light, and units is lux, or it could be foot candles. 10 lux equals 1 foot candles. And the time factor doesn't really apply here. But over on the UV radiation, the iridescence, there's that word again, measurements, is amount of UV, and it's watts per meter square or watts per centimeter square. Now, it does come into play here as far as time. So the dose equals the iridescence, think about this power, times the time. So here, let's compare this. So you got your lux foot candles, you got your watts over on the other side. So that, and then you also, the dose is equal to what we just said, iridescence times time. All right, so let's look at an example here. Back in April in New York City, this was before we really had the availability of a lot of masks in the US, and they were really difficult to find. And New York City was increasing significantly in new cases of COVID. So they did a project there to say, hey, can we clean the masks that we have, the N95 mask, and disinfect and reuse those? So the bottom line answer of all this is yes, we can. The study said yes, using the following. Now we're going to introduce a new term. So the dose is 1.5 joules per centimeter squared. So you see the parentheses, this is the way it's written, 1.5 J over cm squared. Okay, so this is what the parameters were to have a successful disinfectant of those masks. That's the first thing, is the dose. The second is it's a 4-log disinfectant, which we just learned is 99.99%. And then it's used in this specific test chamber. If you change the size of the test chamber or the dimensions or whatever, then that's one of those variables. And so this was all done by 2 groups, one out of the Ressler Polytechnical Institute, and then also the Center for Lighting Enabled Systems and Applications. You're going to get familiar with this term in this group called LESA Laboratory. They worked on this project. Of course, we're thankful that availability of masks moved forward, and this is not as important now, but we didn't know this in March and April of earlier this year. So with this, we've been talking about really the side and introducing the human application of this. And so what I want to do is move this forward, and the impact on humans is really what's important. The science is we learn this to start with, but now we're going to turn over to the impact on humans. So I'd like to invite Aparna to take over and talk about this section. Aparna.
Thank you, Bob. Great job, by the way.
Thank you.
Got a great background on the science of germicidal UV and UVC in particular. At the start of the pandemic, I got very curious about germicidal UV and UVC in particular. And so the question in my mind was, since we know that UVC does in fact deactivate viruses, why aren't we using it everywhere already? Well, the answer is pretty simple. Direct exposure to UVC radiation is harmful to all living beings, humans, pets, plants, not just bacteria and viruses. Next slide. Before I go more deeply into this topic, I would like to take a moment to acknowledge the many organizations who have been tirelessly providing guidance during this pandemic. They've also provided me a great source of credible information for this presentation. I've just been starting to study this since the beginning of the pandemic. I never knew so much till I started this. Next slide. As Bob mentioned, the science to deactivate the virus has been known for many years. Quite simply, once a radiation wavelength hits the virus between 220 and 280 nanometers, the RNA and the DNA is damaged, thus deactivating the virus. We also know that 254 nanometers wavelength is extremely germicidal. Just like Bob said, keep in mind the dosage factor matters. Only the right wavelength of power, exposure, duration, and distance will effectively deactivate the virus. Next slide. The World Health Organization has been taking the lead in the communications worldwide in recommending practices for everyone to keep us safe from the virus and reduce the spread of the COVID-19. This infographic reestablishes the guidance that clearly states UV lamps should not be used to disinfect the skin or hand. And we should continue to use alcohol-based sanitizers, soap and water to sanitize our hands. So in this presentation, in this panel, I will review the known harmful effects of germicidal UV and UV radiation. Next slide. First of all, UVC radiation is harmful to the eyes, just as UVB and UVC are. UVC radiation can cause retinal damage, conjunctivitis, cataracts, painful inflammation of the cornea and of the eye, and could even lead to temporary or permanent vision impairment. Again, any exposure affects is directly the effect of the duration, the wavelength power, and the distance. Germicidal lamp sources may be used when the eyes are shielded from direct viewing. Next slide. Cannot look at it directly or the reflections or the dispersed light from the source. Is very dangerous for eyes. As Bob mentioned, the GUV and the UVC lamps have been used since the 30s for surface and air sanitation. You will see these lamps routinely used to deactivate infectious organisms during the sanitation process in medical facilities. So the medical community is on the forefront of this in unoccupied spaces. Next slide. The next is just as the long-term exposure of the sunlight comes with the UVA and UVB that gets through our atmosphere, causes sunburns and cancer, perhaps, UVC also has an effect on the skin. Since the sun-produced UV rays are blocked by our upper atmosphere, called the ozone layer, thankfully, we can only get UVC radiation exposure from artificial sources. And as Bob mentioned, the UVC has a shorter wavelength and it has a higher radiation energy than the other two UV sources that are commonly getting through our atmosphere from the sun. UVA and UVB penetrate deeper into the skin, while the UVC damages the top layer of the skin with the high energy radiation. So that harm can look like a redness, ulceration, or feel like a very bad sunburn. Again, the effects will depend on the exposure, duration, distance, and power of the UV source. Next slide. The third most harmful effect has to do with the ozone produced by some low pressure mercury vapor lamps. We know that ozone is a toxic gas, toxic to humans. It so happens that the low pressure mercury vapor lamps are the most commonly available germicidal lamps used today for cleansing room, surfaces, and air. These lamps can emit both 185 nanometers, which is optimal for producing ozone, as well as 254 nanometers, which does not cause ozone production. But some lamps emit both. Some lamps are designed to be ozone-free, and some are not. We need to pay attention to the markings on the lamp. Will go more deeply into this. As with all mercury vapor lamps, proper disposal needs to be considered due to the mercury hazard in the lamp. While ozone-producing lamps are commonly used to sanitize the air, inhalation of this ozone is harmful. Just a quick review. The good ozone, as Bob mentioned earlier, is the ozone layer in the upper atmosphere of our planet. It completely blocks the UVC radiation from the sun, thankfully. The ground level ozone is the bad ozone and is created by a chemical reaction in the presence of heat and radiation from the sun that forms between the man-made volatile organic compounds and pollution. Ground level ozone is the top 5 pollutants on Earth. Next slide. So what happens when you breathe ozone? Well, breathing ozone can cause all kinds of unpleasant feelings, triggering coughing, shortness of breath, throat irritation, triggering airways and inflammation of the airways, reduced lung function, can cause harm to the lung tissue, can lead to breathing capacity issue. And if you have any kind of respiratory illness, it just makes it a whole lot worse, like bronchitis and asthma. Next slide. To ensure that you are selecting the reliable germicidal and UVC lamps, we recommend checking for the UL and ETL labeling on the lamps and fixture. Also today, the UL and ETL agencies are evaluating the commercial GUV devices for photobiological risk using the national and internationally recognized standards. These two standards are the ANSI IES RP 27-20 and the IES 62471. Next slide. So at a minimum, when selecting the appropriate germicidal lamp source, you need to consider this if the space is going to be occupied or unoccupied. So for occupied spaces, we want to use only the germicidal and UV lamps that do not cause the production of ozone. And they're typically labeled OF, like ozone free. And I think there's some other labeling that will go into. Never view the germicidal UV or UVC lamps directly or reflected or dispersed, and never use germicidal UV or UVC to sanitize skin or body. In unoccupied spaces where they seem to be used more in the past and even today, those lamps do produce ozone and they can be used in unoccupied spaces, but they must use be used with the proper orientation and procedures, and the space must be completely ventilated after the disinfection process has occurred before human occupation. Finally, as a reminder, the germicidal UV and UVC lamps should always be used in concert with other germicidal sanitation methods. Also be wary of low-price germicidal and UV wands, as they may not be as effective in deactivating the germs or viruses, as Bob had mentioned earlier, and improper use of the germicidal UV or UVC lamps can lead to a false sense of germicidal benefit. So you don't know what you've done if you're not using them properly. Remember that the dosage factor matters. Only the right wavelength power, exposure duration, and distance will cause the virus to deactivate. Always select the right source that is right for your application. And now I'd like to turn it over to Mai, as she'll be presenting more on the GUV and UVC technologies.
Well, thank you, Aparna. Thank you for reviewing the impact that UV has on humans. As you said, we're going to now shift over to the germicidal UV technologies. And one of the largest sources of UV is the sun, like you said. And we actually have known that the sun has disinfecting qualities. And as human beings, you know, just because it's absorbed by the sun, we've actually learned how to harness that same disinfecting qualities with the artificial UV lamps. And so these lamps, the traditional lamps, the UVC lamps, have been around for a long time in the early 1900s. And the lamps of the earlier times look a little different than the lamps that we actually have today. In the earlier lamps, they look more like the incandescent style lamps, but today we're going to focus on the UVC only germicidal lamps. And so one of the largest groups of UV lamps are the mercury vapor lamps, and they come in the low pressure mercury vapor as well as high pressure mercury and low pressure, medium pressure mercury. But the low pressure mercury vapor is the most common of all the UVC lamps, and it has decades of proven use in terms of being around for a long time and been effective as a germicidal lamp. It's also 90% of its emission is at the 254 nanometer peak that you see here on this graph, but it also has a lower peak at the 185 nanometer peak. And traditionally, these lamps have been used across all different applications, including surface and air, and widely used in the HVAC and disinfection robots that's used in the hospitals. It, you know, being widely available, this is the most widely available lamp, like I said, but its high efficiency and lower power and also moderate life makes it a default go-to for most germicidal uses. But just like its fluorescent cousins, it does have some drawbacks in that the UV output is sensitive to ambient temperature and reduced significantly over the life of it. It can go down to 50% or more at the end of life. And with this 185 nanometer peak that you see here, it is a big ozone producer. So like Aparna said, you know, this lamp burns 24/7 a lot of times. So there's a lot of ozone production with that lamp with the optimal production at 185 nanometer peak. But that same disadvantage is sometimes an advantage in that it also is intentional at times because ozone also enhances the germicidal action in the lamp. So low pressure mercury lamps look and operate just like a standard fluorescent lamp, but however, the tube is clear, which allows the UV to come out of the lamp. But in a fluorescent bulb, there's an internal phosphor coating that's inside that lamp bulb that absorbs that UV energy and converts it to visible light. But the same similarities that you see here in this photo, the bulb shape and the base, can also give safety and misapplication issues in the field. And like Aparna said, you can get ozone-free lamps, but they use a special glass for that, and that reduces the 185 nanometer peak that you see here. So it only focuses on the germicidal 254 nanometer peak to make it germicidal, but without producing ozone. And the label is usually marked with an OF, meaning it's ozone-free. So medium and high pressure mercury lamps are also another category of the same mercury vapor lamps. And the medium and high pressure lamps operate at a higher temperature, and it has a broad spectrum between the 200 and 600 nanometer peaks, but it's more lines throughout that peak versus a full broad spectrum. And it's usually used in industrial water treatment, like municipal water treatment plants, because of its high power output in all the different UVA, UVB, and UVC germicidal wavelengths, making it very effective in that use. But also, it's a lower efficiency lamp that it only gets about 10% efficiency, and it also has a warm-up time that you have to deal with. And again, it is a mercury lamp, so therefore it's environmentally, you have to deal with it, and a big ozone producer also. So here's another less common but highly effective source, and it's the UV Pulsed Xenon. And this lamp emits a high power pulses in a more broad spectrum in the UV visible and the IR range. So across the entire range. But for germicidal applications, it's usually filtered to emit only the UV radiation. And it's, it needs to be used when no humans are occupying the space, because it is a very intense lamp. And these applications are also for disinfecting of air and surfaces, and also HVAC, and widely used in the disinfection robots. Because of its high power, it's much faster and more effective than the low pressure mercury vapor lamps. And then also, since it's a pulse lamp, it doesn't have to operate in very long periods of time. So it's very quick and effective. It does have a long life. And it also is a relatively higher cost lamp than the mercury vapor lamps. So emerging technology is bringing new UV sources to the market. And here's two examples. One is the Excimer, the far UVC lamp, and the other is the UVC LED lamps. The Excimer lamp, which some people call the far UVC lamps, it's known in the industry as both the Excimer or far UVC. You see it referred to that. But the far UVC is a subclassification of the overall UVC. So if you see here, it's in the shorter wavelengths between 200 and 225 nanometer range, whereas the UVC goes up to the 280 nanometer range. But with Excimer lamps, it is usually filtered to emit only a single wavelength. And two of the most germicidal wavelengths for Excimer lamps is the 222 nanometer and also the 207 nanometer peaks. And we expect this to be used mostly for surface and air applications, but it is a new lamp. It's new, but it's getting a lot of attention these days. And that's probably because it's, they're claiming it to be potentially safe to be used in occupied spaces without posing a health risk. So if you recall what Aparna said, most of the UV lamps can't be used in spaces because of their exposure, could be harmful to humans. Well, that's a manufacturer claim at this particular point in time, because it is fairly new and there's really early research that's going on. So we're hoping to hear more from that. It is a high efficiency source because of the lower 222 nanometer peak, the wavelength. And it's also allows it to be on off at full output. And as you can see here, it gets 100% output at full on and off, but it also is not affected by the ambient temperature. And this little, as it is with low pressure mercury vapor, you see on here on that blue curve is low pressure mercury, which is affected by the ambient temperature, and Excimer lamps are not. It does come at a relatively higher cost, and since it's very new, it's very limited in product availability these days. But like I said, I would stay tuned because I expect a lot more to come on that, because there's a lot of tension of it possibly being safely used in occupied spaces. And that's why there's so much attention to that lamp. Another emerging technology is the UVC LEDs. We've always seen lately lighting LEDs are as popular as ever, but the UVC LEDs are fairly new, especially in the germicidal, larger room applications. It has a wider choice of narrowband wavelengths, and it's between the 255 and 280 nanometer, which is kind of optimal, because if you remember what Bob said, there's a germicidal peak effectiveness curve, and at 265 nanometer is the peak germicidal effectiveness. And fortunately for UV LEDs, they generally can get their peak performance is about at that peak effectiveness curve. So between 255 and 280 nanometer wavelength, they can dial it in, different wavelengths around there. And we expect the applications to be widely used, probably in the surface and air disinfection, but it's currently being used right now for water disinfection, also for more close by point of use applications, like possibly water filtering, like at your house, or small area water, not the municipal water treatment like we talked earlier. But just like it's, the lighting cousins, the UV LEDs will be easier to implement into products because of its compact and lightweight form factor. And it's also low power. So I expect it to be able to be battery powered and also used in remote locations because it can be battery powered. And it also can be turned on and off, withstand, that instant on off use. And just similarly to the lighting LEDs, it have a longer life, but it is much shorter than the lighting LEDs. But that long life also allows manufacturers to prioritize the power over the life, because germicidal action is what they're looking to gain from the products. It is also a relatively higher cost product. At this point in time, it is a lower output, but it is improving as technology is improving. And the room-based applications products are limited in its availability. But, with the current situation that we're doing with the pent-up demand for germicidal products, I expect it to go much faster now, and then also as advances in technology that are just being uncovered these days. So stay tuned. I expect a lot more to happen. So we just covered what the UVC lamps have, that are available to us. So let's continue on to disinfecting solutions, because this is some of the areas that you all are interested in seeing. We know that hand washing and hand sanitizing is an excellent low-tech way to disinfect and to minimize transmission of pathogens. We also know that COVID these days is bringing about enhanced cleaning protocols in a lot of our spaces. But with the enhanced cleaning, there's much more use of chemicals, and chemicals also have some downsides, which is, such as bacterial resistance to these chemicals, and also the need for ventilation of spaces as we use the chemicals within our spaces. And then also we're seeing screening procedures being implemented, like temperature checks or masks, checking for masks before entry into a space to minimize the introduction of infected individuals. But what these procedures don't do is address the pathogen introduction once a person is in that space. And so, or carriers, the asymptomatic carriers. It's a hard word to say. It's a tongue twister. But anyways, So, it doesn't address that once you're in the space. And so many of you guys out there that have joined us today are looking for different ways to deal with, disinfecting our areas that are our work areas, or also disinfecting the air in our buildings, and then also room-based solutions. So I'm going to review some of those next. So here's some technologies that are available that will address local area disinfection. Here's the UV entry portal that is fairly new and came to the market. But you can also do local area cleaning either through HEPA air filtering devices, or also UV disinfecting exchangers. And those are small room based or local area based. And then hospitals have been using mobile UV disinfection robots for a long time. But now that there's demand in the commercial applications, they're being brought into like airplanes, and I've seen them in hotels and things like that. Building air cleaning is also something that we're being asked to address these days. And you can clean the building air through natural or mechanical ventilation. But you can either open your windows or pull in air through the mechanical units. But that also introduces other pollutants into the space, possibly, especially if you're air outside, such as smog, like Aparna mentioned, or different times of year, there's also more pollutants in the air. And then HVAC systems, have traditionally used air filtration. Now they've stepped up that type of filtering, if they can, to clean the airs mechanically. And then also another method is using germicidal UV in the air handling units. And there's usually two types of, germicidal uses in the HVAC system. One is focused on treating the coils. And what that does is prevents the mold growth on the coils, and then also prevents mold then being blown into your spaces. And the other one is to treat the air in the ducts. And that treats the air as it's passing through, pulling from the room into the ducts, and it treats it as it's going through. But right now, they usually use traditionally the low pressure mercury vapor lamps, just because they're readily available and have been effective and probably cost effective too. But there's a lot of energy and maintenance required because they burn 24/7, and they have to be replaced annually because of the long burn cycle. So that gets expensive. But one thing to note is HVAC is cleaning the air in the buildings, but it's not effective in preventing person-to-person transmission. So it does not, it's not an effective means to prevent that transmission when that person is in that same room with you, because of the limited air exchanges that we actually have. So that's why commercial room disinfection units are more applicable when the transmission is in the room. And so here's 3 particular samples of commercial room disinfection technologies that are available. So the one on the left is the same as that could be used locally, but for small rooms, it's an effective way to irradiate the air. But this is only effective, this one here is only effective for smaller rooms because of the limited air exchanges it can do. In the center here, there's automated or on-demand germicidal UV devices, and these are useful for like direct disinfection of the surfaces, like especially high-touch surfaces, and also is effective at room air disinfection when it's unoccupied. But the unit here on the right is considered an upper air germicidal UV disinfection unit, and these are used to irradiate air in the upper rooms. So IAS and CDC, the Centers for Disease Control, recommends that upper room germicidal UV used as a primary method to disinfect the larger volumes of air and to do it effectively to reduce the spread of airborne viruses. And we know that, I think it was Aparna or Bob said that this, we've been doing disinfection for 70 more years. Well, the upper room germicidal units have been effective for also minimizing the spread of measles and tuberculosis, and it's still being used in other areas of the world, which still has problems. And now with the pandemic times, I think we're getting a lot more demand in United States too. This particular method is great at disinfecting large volumes of air. As the air passes up in the upper zone, it irradiates it as it passes past the UV rays of the upper room UV fixtures. But I think you recall that Aparna said that you usually don't use it when it's occupied, UV in occupied spaces. Well, upper room germicidal UV units do allow you to use it while it's occupied. And that's because the units are located up high above the occupants which is below this in the space. And it's also out of the direct line of exposure that it can be harmful. So again, this particular method can be used while it's occupied. And that's makes it very good and a safe and effective installation. But it also requires that it has a proper install and commissioning. And then also training of the staff is important, especially for safe operation and maintenance. Again, a knowledgeable consultant is recommended because there's some technicalities of it to make sure that it's effective and designed properly. So here's some units here that is taking what's typically been used in industrial or clinical settings into the commercial applications. So upper room GUV units typically do look very industrial looking, but here's a new novel approach in that it combines and integrates several different systems needs like lighting and acoustics, along with a germicidal UV in the upper zone. And that helps to reduce the overall cost and makes the air disinfection being able to be integrated seamlessly. And then also, it reduces, like I said, reduces the cost of the overall building system. And again, this is just an example of one. There's multiple. So let's take a moment. We're going to pause and review what we just learned today. So we know that UVC is germicidal, and that's what Bob said. And Aparna mentioned that there's what precautions that we need to consider if we're going to use it safely. And I just reviewed what the germicidal UV technologies that are available today. So what do you do with this? So all of you are here because you want to know what the guidance is to implement the germicidal UV in your facilities. Then it makes sense that we take our lead from the medical facilities because they've been doing it for a long, long time. And it's been doing it successfully to reduce the transmission of diseases. So both IES and CDC have guidelines for the environmental disinfection for healthcare facilities. So, if we know what those guidelines are, we can use them effectively for other spaces as well. So germicidal UV in the upper room fixtures, we can also do as an alternative because some of the rooms the geometry won't allow us to use upper room germicidal UV units. And we can use high quality local room germicidal units to clean the air in the spaces. So the second thing that the IES and CDC recommends is also including mobile or fixed direct germicidal units, but with occupancy sensors to allow for safe applications. And this is to disinfect the high touch surfaces. And the third thing that IES and CDC recommend is using germicidal UV in the HVAC air handling units. And this is to treat the recirculated air and the reduce mold on the coils. So all these, all three are recommended. And then if you do multiple layers. This allows additive reduction of the pathogen and viral load overall in your spaces. And it, ultimately reduces the risk of transmission. And that's really what our goal is. So these are the 3 different methods that CDC and IES recommends. And so this actually ends our formal presentation. Lynn, you can switch it, advance it, please. And here's some references and resources that are available to you that you can actually go see on your own time. And now we're going to transition over to Lynn, who's going to manage the Q&A session. So thank you.
Thank you very much, Mai. Very informative, a lot of great information there. Sorry for the little glitch at the end. Sometimes that happens with webinars. I thought before we would take general questions that I would just go through some key points that Mai, Aparna, and Bob had outlined for me that helped me understand this better. The first was the main takeaways from today's talk. So there are 4 main takeaways. First, that UVC can be effective against bacteria, viruses, and other pathogens. Second, that UV technology has been used effectively and safely since the 1930s. So there is a strong body of evidence. Third, low pressure mercury is the most common source for UVC radiation, but there are other sources coming on like LEDs and Excimer lamps that Mai told us about. And the 4th takeaway, hopefully you got this throughout, is that this technology is going to affect the lives of everyone and will also have a direct impact on the lives of lighting practitioners. If we look into details a little bit more about what we need to know about germicidal UV disinfection technologies, remember Bob outlined 3 main points. You want to know about the UV source strength, which is measured in radiant watts, the distance of your specimen being treated from the source, and the time of exposure. So there's a lot of similarities with the common lighting measurements that we do. There are some differences, as Bob went through, but also some similarities. As Aparna touched on, the main dangers of UVC, there are really 2 main dangers that we need to be aware of. First is the danger to our skin and in our eyes coming from direct UV exposure. Remember, we're talking about UVC, which is actually more energetic than the UVA and UVB that causes sunburn. UVC is actually fortunately absorbed by the ozone layer and naturally doesn't reach the surface. So there's only man-made UVC, but we still have to protect our skin and our eyes from direct exposure. The other danger is the danger from ozone generation. UV radiation below 200 nanometers will produce ozone. So as both Aparna and Mai pointed out, if you have a lamp that is radiating below 200 nanometers, there's always the risk of ozone. And ozone has a lot of respiratory issues, and you want to avoid that, or at least always provide adequate ventilation. So what level of germicidal treatment is needed? Well, the short answer is it depends. It depends on exactly the pathogen you're dealing with and what the level of treatment that you need. A 2-log treatment, as Bob pointed out, would equate to the inactivation of 99% of the pathogens, and that's called the D99 number. Likewise, a 3 or 4 log inactivation or treatment would produce 99.9% for a 3 log or 99.99% for a 4 log treatment. And finally, does all UV kill all viruses and bacteria? And the short answer is no. As we heard, the efficacy of UVA is pretty low for treatment of viruses, bacteria, and spores. UVB is a little bit better, but UVC is really where we get into germicidal action. So really only germicidal UVC in the 200 to 280 nanometer range is what we would be treating with. And so the bottom line is, before you make investment in a product, be sure you understand what the source is, what the wavelength it's producing, and what the power level is. I would like to thank our panelists. I know they put a lot of time and effort into this, so not only preparing the slides, but practicing, but I'd really would like to extend my thanks, and I'm sure everyone in the section would, for the great job by Bob, Aparna, and Mai on this wonderful presentation.